Hey, it's Bill Trombley from Trombley Tool in East Troy, Wisconsin. What we have here is a cowling for a 1935 Fairchild 24. Very early Fairchilds. So this would be a Warner powered. This will be for a radial engine. It's the classic teardrop shaped cowling. Pretty cool. And what we have to do is, the issue with these cowls is that they're one piece. So what happens is anytime you have to service the engine, you have to take the propeller off. So a lot of these get split, and then it turns them into two halves, and then they're easier to do engine maintenance. So what I have to do is build basically to look like a wing rib or a structural piece, a rib, that would get mounted in this area here, and there'll be one on both sides of the split, and that way then those two ribs could come together and get bolted together to bring the two halves of the cowling together. So what this video is tonight is how do you make an accurate template of this profile. So this here, it actually is a radius here, and then in here it almost appears to be hollow. It's not perfectly flat. A little bit uneven, and then it flares out here at the very bottom in this section here. And you know, for us, we have to have it where when I make the form block and I make that internal rib piece, that it actually matches this outer skin all the way. You know, in earlier videos we had talked about we can't rivet over an air gap. So we need to have it so it matches that profile completely. People have taken and they go, well, you could do it by having a board and you cut it so it's kind of close with a bandsaw, and then you try to trace the lines, and you could use a compass and you know, then sand it close, and sand and sand and sand and sand, and you know, to try to eventually wiggle your way in to get it so that you would have an accurate representation of what this profile is. You'll see there are those body profile gauges that'll have all the little needles on them. Those I don't think work very well. They get you close. But I want something that's accurate, like super accurate. Another problems with those things with all the little pins on it is you bump it. You know, they don't make them so they lock. Also finding one that's this long there too. So those are all challenges associated with it, and I suppose there's a number of ways it could be done. But I wanted an actual takeoff of this exact surface, and this process works for many different things. I had to repair a 1964 Aston Martin DB4. This was a couple of years ago, and the whole lower portion of the car had heavy corrosion in it. So I wanted to take the driver's side was better than the passenger side in certain spots, and vice versa. The rear pan that goes underneath the bumper was damaged. But I wanted to have accurate profiles, representations of certain spots, so that then I could use that when going along the car. And I used this process for that. I actually use this process all the time. This process, I learned this process over 30 years ago. My best friend that I grew up with, his dad was a pattern maker, and still is, he's retired. And he had taught me this. I was working on a Lockheed PB-2 Harpoon, and inside the wing, all the leading edge wing ribs were cut out with tin snips, and that airplane was actually a crop duster, kind of neat. Twin engine Navy bomber is a crop duster, but it was, and so down the leading edge they had cut out all the leading edge ribs to put in auger tubes for the pellets that they had that they were crop dusting with. So we had to build up new wing ribs on the inside. So here it is, I have this profile, and now I have to match this profile. And my friend's dad showed me how to do it. And this is his process. I slightly changed it over the years, but it's still not an extremely accurate result. And we'll go through it step by step. So the first thing is you have to lay out a line that is true. And what I mean by that is I don't want to build a template board that's actually crooked on this cowling. And it's easier than you think. So the easiest thing to do is laser line. This is a Bosch laser. Got this from Home Depot. It's inexpensive, and it guarantees a vertical and horizontal line. I use this thing a lot. What's nice is it's a radius profile, and it will scan or project a perfectly vertical or horizontal line over a contour. So I use this for building bucks. We use this to determine center lines. We use this to determine if something is screwed up. Might visually look not quite right. Shine a laser light down it and you can find where the discrepancy is. So it's a pretty inexpensive investment, and I use it all the time. What's nice is it's inexpensive enough that if I drop it, I would feel bad, but I'm not out $1,000 later. I'm out a $69 laser. Not that bad. It's designed to mount the tripod too, which is nice. We have a project here in the shop just last week that we're shining a laser light down to find, it visually looks wrong. We shined the laser light down the project and you could see where the discrepancies were. So I want to cast a vertical line on this. So my workbench is level, set the cowling on there, cast a vertical line with the laser, and then I drew a Sharpie line on it. And you can see it lines up perfectly. Probably not, I don't know how well it'll show up in there on the video, but it's a perfect vertical line. So that's important, because we don't want a template board that's crooked to that, right? Because the line is where I'm going to build the rib, is the way of thinking of it. So now that the line is on there, I take, and there's two ways you could do it. I use Johnson's paste wax. This is SC Johnson's paste wax. The benefit of this is it's non-drying. I think this was originally for doing hardwood floors. Hardware stores will carry it. I've had this can now for 30 years or more. I bought this can when I started that project on the PV2 Harpoon. And what I'm doing is I'm coating the surface, and I'm going to use it as a mold release. And it's actually going to be real close to this line. And you'll see why here shortly. Obviously, if you're going to make a template, you want to make it a template of an area that doesn't have a dent in it, or otherwise you'll be making a template of the dented area. You would think that's obvious. But what I think is obvious isn't always the same for everyone else. So now it's coated with a paste wax. Let's say, and I've had to do this, we had to make cowlings for a de Havilland Tiger Moth, World War II primary trainer that was used in England. We had a customer come by. His Tiger Moth was a finished project. It was a finished airplane. It was flying. It was airworthy, and it was painted a matte finish. And I needed to know how the profile of his cowling looked, the side cowls. So the last thing I wanted to do on a matte finished camouflage paint job was take Johnson's paste wax and smear it all over the side of his airplane. In addition to that, when people see this process, they're not going to let you go along a finished Bugatti and paint paste wax over it and then build the template board. So what you can do is wax paper. As long as it's a mold release, it's all that matters. So like on that de Havilland chipmunk, or Tiger Moth, took a piece of wax paper and put it on the side of his cowling and stuck it on with masking tape. And then I took my profile boards over the wax paper. That way it never none of this products or anything ever touch the finished surface. So that way, no one's upset with this. We've had to do work where we've had to go to museums to get information. So now they got an airplane on static display in the museum. Museum curators are not going to be happy if you start doing this process on an airplane. So you got to be able to protect it. So if you can't use paste wax directly, wax paper will work just fine, and tape it onto the surface. Same thing is like I can cast the black line on there is put the wax paper on and then shine the laser light on the wax paper and mark the wax paper. So you don't have to mark it directly on the surface. This cowling here has got a gray primer on it. There's corrosion that's peeking through the primer. So this is all going to have to get stripped and repaired, and there's weld repairs that are going to have to get put into this. There's some corrosions that have to be fixed. There's some old repairs that are going to have to get changed out. So the fact that I pasted this on there and drew the line on there, it doesn't matter. So now what we do is take this here, and what this is, you can actually buy this stuff from Home Depot, and it's plastic cardboard is the best way to describe it. They use it for signboards. Sign shops will use it. Normal paper cardboard would work, but I like this stuff. It's more stiffer, it's stronger than using paper cardboard. And there's a reason why I'm using it, and that's because of the corrugations, the hollow corrugations. So I have the corrugations are running this way in this cardboard instead of running them this way. And you'll see why in the next step. So what I do though is I take and I rough cut this out until it's pretty darn close, like very close. And I have this is a shear I bought many years ago. It's made by Craftsman. It's nothing particularly special. This is what I use for cutting sandpaper, because it's like only use ever one shear for cutting sandpaper, because if you wear it out, you know, who cares, instead of wearing out all of your other shears. But it cuts this plastic cardboard really efficiently. So just picture I take and I rough draw a line on there, I eyeball it, get it kind of close, and take the shear and I'm cutting it out with a scissors. And I'm trying to get this to be within 1/8 of an inch or 1/4 inch of the surface. You don't really want much more than that. If this is, you have a high or a low drum sander on a die grinder, or a flap wheel, sanding disc, 2-inch diameter roll lock on a die grinder, and this actually will sand pretty good. And you can see where I actually did that in this radius right here. You can see the burr from it. It doesn't matter for our application. This is just to get it roughed out close. So now I have a template board that is pretty darn close to this surface. And now what we do is we have set up over here is a can of Bondo. The only time I ever have body filler, the only use for Bondo in my entire shop is for this process. And what we're going to do is, and I've explained this process to some guys, and they instantly understood it. I've explained this process to other guys, and they had no clue what I was talking about. So I thought if I showed the process, maybe this will help. My friend's dad, his name's Larry, and he's actually not far from here. Really cool guy, knows his stuff. He used a product, he didn't use Bondo, it was a plastic, it was similar to this, it was a 2-part mix-up. And he says, you don't want to use Bondo because it shrinks. Well, for him, he's building patterns where a couple thousandths of an inch matters. So is there shrinkage in this? There is. So is this exactly accurate? It's within a few thousandths of the surface because I have shrinkage of technically of the Bondo. The reason why I mention that is some guys go, well, geez, well then you're not making accurate parts. It's like we're hand shaping metal panels. I ask anyone to show me how they're making their parts as tight or tighter than what I'm making. My parts, I can fit them so tight to a buck that you gotta pop them off with a little pry bar. So there's a couple of thousandths of an inaccuracy here. I'm not as concerned about. Another thing that he would do is he wouldn't use the plastic cardboard. He would use hardboard, masonite. I think is what you call it. It's a brown board. You can get it like from Home Depot. You put it like on a workbench tabletop. And then to get the Bondo or the plastic filler to stick, is he had taken V-notch along this edge in the bandsaw, so that way he could push that on there and get that plastic to stick on the edge. The reason for this cardboard is when I smear the Bondo on, the Bondo will actually push down into the corrugations of the cardboard and mechanically lock it into this plastic cardboard. So this is extremely similar to what he was doing with a couple of changes. Another benefit is like his products were coming from Freeman Supply, which is local here in Milwaukee, but they're down by Mitchell Field. It's a 45-minute drive from here. They used to be closer, and then the stuff's expensive. Well, here I can get the cardboard from Home Depot. Home Depot even sells Bondo, so it's like what, $12, $15 for this can, and this stuff, I don't know, what, $10 for 8-foot sheet or something like that. Lasts a lifetime. So what we're gonna do is mix this up. Now for you auto body guys watching me mix Bondo, you're probably going, oh my God, never ever mix Bondo this way. Well, this is the only way I ever known because I don't do anything else with Bondo. And I'm sure there's a better way, but I'll be honest with you, I don't even know if I care if there is a better way. Maybe a little bit. Like, how much harder do you put it? For the love of God, I have no idea. So, mix this up. So this is an extremely fast and super accurate way of taking a takeoff. And super, well, yeah, easy peasy. And what you do is you paste it on here like this. And on bigger panels, I've had to have the guys in the shop help me because it's not always the easiest, and I tend to probably mix my Bondo too hot, so it sets up quick, which is also another frustration. So now that I have it pasted on there, like that, so Bondo is on the edge, I find my Blackmagic marker line and I push this on. So now I know that my template board is straight. Like this, and that I'm getting an accurate representation of the surface. So I take my finger and I kind of push this Bondo around a little bit. Like that. So then what will happen is the Bondo sets up and becomes hard. And because it has mold release on, I can take this piece of cardboard and I can just move it and break it, and the bond will be released and this panel will come off. And now what I have is a hard plastic edge that perfectly matches the profile. And let's say you looked at it and go, well, there's a little gap or something. Well, before you pop it off, mix up a little bit more Bondo, let it get hard, and smear some more in there. Once this pops off, I take a die grinder and I sand the Bondo down to the cardboard on one side. So now I got a perfect hard shoulder that I can then take a scriber and scribe onto my form blocks. I can then offset for material thicknesses and all of this kind of stuff. But I have a form or an accurate template board of the exact surface. And this accuracy is within the distance of the shrinkage of the plastic Bondo or filler itself. For which I would argue is so close that it's almost non-measurable. And also too, I think these new plastic fillers probably shrink a whole lot less than the early plastic fillers or Bondos, especially from 30 years ago or longer. You know, he'd been in the industry for a long time. So, hope it makes sense. You can see it's a simple process. It's a very accurate process. And it's all stuff that you can do with simple parts at home or in your workshop. And probably with a lot of product that you actually already have in your shop. So let me know what you think. If you like this idea, like I said, we use it quite often. And let me know what you think. Like, subscribe, tell all your friends, and have a good day. Thanks. Bye.